For those of you who do not know me, my name is Iris Abiasa, and I am on the e-board of the Department of Information Systems Club, also known as DISC. I am going to hand it over to my president, Riddhi, to share a little bit more about what DISC is, and then after that, we're going to hand it over to Edwith to share with our DISC member what AI Club does. So I think I can share my screen. All right, take it away, Riddhi.
Hello, everyone. I am Riddhi, and I am the president for the Department of Information Systems Club. Move to the next slide. Yeah. If you don't know about us, please feel free to follow us on social media. I'm going to give you a few seconds to do that before I explain to you what DISC is about.
And we are most active on our Instagram for the latest updates, but we once in a while update our other social media pages. So yeah. And then if you sign up on Sun Devil Sync, you will be able to receive our weekly newsletters to get updates about our events, job postings, and other things relating to information systems here at ASU.
All right, so for those of you who are new to DISC, we are a dynamic social organization comprised of motivated professionals in training who are well-versed in both information technologies and business. So in simpler words, we are a student organization that tries to expose our members to both business and technology, and just help them become well-versed in both. There is no fee to be a member of DISC. It is our membership is completely free. However, what you need to do to be a member is there are certain requirements to be a member. The first one is sign up on Sun Devil Sync. Here is the bit.ly for that. Fill out the registration form that's on there and attend 3 general meetings and 1 community service event per year. That's when you become an active member, and that's when you can add DISC on your resume.
Members also get perks such as attending the annual information systems conference and other perks such as getting cool swag like t-shirts, caps, water bottles, and stickers.
Yeah, and we focus on our members' professional development. So we provide you with too many opportunities to network with professionals. We bring in companies every other week. So you can have one-on-one conversations with them. You can make connections. You can hear from them what they're looking for in candidates for internships and jobs. We also hold resume building workshops and mock interviews. So it's a really, really great organization to be a part of if you really want to focus on your professional development, because we really expose you to we give you the exposure and we try to provide you with the skills and the overall confidence that you need to thrive in this industry. This uses Remind to send out reminders about our upcoming events. So if you're interested in receiving those, please scan this QR code and sign up to receive our reminders. We have 6 committees and skip the slide. We have 6 committees: community service, event planning, finance, instruction, IT, and women in tech. And our committee heads generally are in need of help to hold their events. So please scan this QR code if you would like to become a member of a committee. As I said, our committee heads are in need of help most of the times when they are planning their events. So if you want to help them out, please join a committee. You can join as many committees as you'd like. Next slide, please. So these are our upcoming events. April 1st is our general meeting with American Express. April 8th is our general meeting with Group Source. And then finally, we are going to end the year. I can't believe it's already been a year. We're going to end the year with our end of the year social on April 15th. Other events are March 28th is the deadline to nominate DISC or any other student organization that you're a part of for WPC, BSc awards. March 30th is the Department of Information Systems Connect at 11 a.m. April 9th and 10th is the AIS Student Leadership Conference. So officers, active members, incoming officers, I hope that you all have been invited to this. And I would highly encourage you all to participate in it and attend the conference because it's a great learning experience. I have attended one and I can definitely vouch for the fact that it's a really informative workshop. It's great. And then finally, April 14th is Pictionary with faculty. It's like a fun game night, or actually afternoon with faculty members.
And just to clarify, most of these events that fall under the other category are specifically for information students, but definitely under the general meetings. If any of these two companies seem interesting to you, we encourage you to attend our meetings on Thursdays at 6 p.m. All right, and that's it for me. And Riddhi, anything else to add?
Nope, that's all I had.
All right, thank you so much. And let us know if you have any questions in the chat. All right, passing the baton over to the AI Club and share with us about what they do.
Sounds good. All right, just give me 2 seconds. Okay, cool. Do you guys see this?
We can
Cool.
see it.
Awesome. Awesome. First of all, that was a really fun introduction. I like the icebreaker game. I think all of our members enjoyed it as well. Nice to meet you guys. My name is Adwith. I am a 4+1 student here at ASU, currently doing my master's in computer engineering. And I currently serve as the president of the Artificial Intelligence Club currently. So actually, fun fact is next semester, we will be looking for new officers to join our team. So I'll tell you a little bit more about that after I talk a little bit about what we do. So at the AI Club, we pretty much cover everything from artificial intelligence to machine learning. In this club, you guys will get to learn a little bit more about what AI is, how's it used in today's society, what are some cool products that are using AI concepts or machine learning concepts for that matter. And we just cover everything that can hopefully give you a better understanding of what artificial intelligence is. Now, this isn't like a course or anything, so it's pretty beginner friendly. If you don't have any experience, that's completely fine. There's no prerequisite knowledge required, and I think if you're just looking for just a general way to make friends or get to know professionals, we have lots of people come from different companies come in, like State Farm. We had Raytheon come in recently. We just have a bunch of different companies come in, talk a little bit about what they're working on in some of their projects, and it's a great way to make connections as well. Other things is we have a ton of workshops, which basically get to teach you guys a little bit more about how you can get more involved with artificial intelligence and machine learning. So this is going to be one of those workshops where it's a little bit hands-on, and hopefully you guys gain a little bit more from it towards the end. But yeah, anyways, I guess the last thing I wanted to say was, so if you're interested in becoming an officer, no prerequisite knowledge is required. we're going to be looking for new officers next semester. There's going to be a new leadership team. Jamie, if you could post all of our information, or James, one of you guys, if you could post all of our information in the chat, that would be super helpful. Perfect. It is there. Awesome. So there you'll find our YouTube channel. So we always post if you can't make it to our meetings, usually we record all of our meetings and we post it on our YouTube channel. You can follow it there. Also, you'll find the AI Club email. So if you're interested in becoming an officer, go ahead and send an email introducing who you are, stating your interest in running for an officer, and we'll get back to you as soon as possible. You can also join our club like as a normal member on Sun Devil Sync. The link's in the chat as well. Apart from that, does anybody have any questions before we get started with the workshop? Sick. Okay, cool. I'll take that as a no. We cool to get started then? Is that cool with everyone? Awesome. Sweet. So today we're going to be talking a little bit, about supervised learning. Agenda. So this is what we're going to be doing. I'm going to reintroduce myself, I guess, again, if you haven't gotten bored of me already. And then we'll go ahead and talk a little bit about what is supervised learning. We're going to talk about what machine learning algorithm we're going to be implementing, which is linear regression. It's pretty simple to implement. And finally, hopefully you guys will find this interesting, but we're going to build our student grade predictor. So essentially, we're going to develop a model that can predict what is a student's final grade based on what their past grades were and what are their current behaviors. So it's not as hard as it sounds. It's actually pretty simple. But yeah, let's get started. Cool. About me. So like I mentioned before, I'm a 4+1 student doing my master's in computer engineering. Hoorah. I also work as president of the AI Club, and I'm a GPSA assembly member. Fun fact, I guess, is I will be interning at Goldman Sachs as an operations analyst. Cool. Awesome. So let's go ahead and jump into it. All right. What is supervised learning? Before I kind of talk about what is supervised learning, does anyone have a brief idea that they want to share? You can unmute yourself. You could put it in the chat, whatever works. If not, that's completely cool too.
Right. I think supervised learning is just using historical data to kind of predict something, whatever we want to predict, whether that be stock prices or, I don't know, your grades, the weather.
Yeah, exactly. That's a great definition, a great example. Anyone else want to share anything there, what their thoughts are? Is there any Discord server of the club? There is no Discord server, but we do have a Slack channel. Jamie, James, any officer, if you guys could send the link on there, that'd be super cool. Awesome, thank you. Yeah, no, Ira, that was a great example of what supervised learning is. So supervised learning basically is one of the branches of machine learning where you get to train your model using labeled data. What do I mean by labeled data? Labeled data is essentially you're giving your model an input data set, say for our instance, we're going to be giving our model, here are the students' past grades and some of their study patterns. And we're also giving our label data, which is our known output data, to our model. What that model is going to do is we're going to train our model against that training data and compare it on the test data to see if it made the correct prediction or not. Once we train it enough to where it's pretty smart, we're going to actually test that model on our test data set. And that's how really supervised learning works. So basically it's like teaching a toddler. You're teaching a toddler how to, maybe not a toddler, let's say a little kid. We're teaching a little kid how to do math problems. We show them example math problems and they get the hang of it, of the concepts. Then we show them problems that they haven't seen before. That's our test data set. So that's pretty much what supervised learning is. This just reiterates what I said. So there's just 3 simple steps in supervised learning, supervised machine learning. The first step, gather all your labeled training data. So there are a ton of machine learning repositories out there that are really fun to use. So we're going to be using University of California, Irvine's ML repository. And basically that repository has like, and by the way, a repository is just think of it as a huge like database of information like that you can pull information from. We're going to be pulling our student grades data set from there. And that's what we are going to do when gathering our label training data. Second step, we just split the data into 3 sets, our training, testing, and validation. So validation gets a little bit more complex, it's a little bit more time consuming. So because I don't want to keep you guys to like for a long time, I'm going to just look at the training set and the testing set. That's what we're going to look at. So what is the training set? The training set is used to train the model to minimize the error. So basically we're training our child, for lack of better analogy, we're training our child to do some practice problems and understand a relationship. Then our test set is what provides the real world evaluation of the model's performance on data that hasn't been seen before. So we're going to be basically giving that child new problems to solve, and hopefully that child can solve it based on based on a proper understanding of the concepts. The final step, and the third and final step, is basically where you train, test, and evaluate your model. So you're just seeing if your model works or not. And we're going to use accuracy to measure how accurate is our model when making predictions. By the way, if I'm going too fast or anything, feel free to interrupt me, ask any questions, by all means, guys. Cool. So there are 3 types of machine learning: supervised, unsupervised, and reinforcement. So in supervised learning, you can work with 2 concepts: classification and regression. So some projects, some really cool fun projects that you could probably do on your own include fraud detection, email spam detection, diagnostics, image classification, and that like analyzing an iris data flower from an iris data set. That's all in classification. And then regression is for risk assessment and score prediction. So that's what you can really do with supervised learning. Now you can also go down the unsupervised, like that includes text mining and facial recognition, and that falls under something called dimensionality reduction. That's a little bit more complex. We won't be talking about this today. And if you're interested in biology, you can really learn the clustering aspects of unsupervised learning. The final branch is reinforcement learning. And really, if you're interested in the stock market or the finance sector, RL is really, really interesting to dive into. It's something a little bit more complex, but that's something. We have another workshop that'll be presented next semester that'll talk a little bit more about RL. But anyways, in this image you can see right here, I already talked about this, but in supervised learning, you have raw data or input raw data. So this is a picture of tomatoes. And here's our machine learning algorithm. So in this case, it's our linear regression algorithm. We feed our data to our algorithm. Our model will process that data and it'll make a prediction. And therefore, like it'll say like, oh, okay, it's a tomato. Otherwise, if it guesses incorrectly, it'll say like, oh, it's an apple, right? So that's really all supervised learning is. It's not as complex as it sounds. All right, so this is probably the last slide on linear regression, or the only slide. So the machine learning algorithm will be applying, or the supervised machine learning algorithm is linear regression. So most of you know about linear regression through like algebra, pre-calc. It's essentially where you fit a line of best fit on a 2-dimensional graph. You can have it on a multi-dimensional graph if you use more attributes to analyze, but we're not going to make it that complex. We're just going to be looking at a couple attributes and we're going to be plotting it on a 2-dimensional graph on the x-axis and y-axis. Our objective is to basically determine what is the correlation between the x-axis and the y-axis. What is the relationship? And we do that by applying the line of best fit on our data. So the line of best fit, you can use, the computer will automatically compute it for you when it's just one line of code, which will apply this equation, your y equals mx plus b equation. So that's pretty much it. There's an image I'll explain in the next slide. But yeah, so one of the advantages of linear regression is it's really easy to implement. It's versatile, so you can use it in a lot of scenarios, and you can use it for classification, regression, and search. The disadvantage is though, when you're using linear regression and say you have a graph like this and you have points that are far away from your line of best fit, that can quite often mess up your line of best fit and skew your data. So that's one of the times where you don't necessarily want to use linear regression. Cool. So that's that about the algorithm. Now, what we're going to be building is something called a student grade predictor. Essentially, we want to predict a student's final grade based on what their student behavior is and what their past grades are. So in this case, in our data set, which I'll show you guys how to pull from University of California or UCI's machine learning repository, we're going to be looking at the following attributes. We're going to be looking at their grades from their first trimester, G1, their second trimester, G2, their study time, so how many hours do they study for an exam, the number of failures they experience in a semester, and their number of absences. Keep in mind, these are all integer values, and we're going to be predicting what their final grade is. That's G3. And don't worry, I'm not expecting you guys to remember this. I'll be repeating myself as we go through the code. But yeah, so essentially this is what we are going to try to achieve. This is not what it's actually like, what our end model is like. This is just like a sample, right? So essentially you could see there's a linear relationship. As a student continues to study more and more and put more time into it, the percentage score they achieve on an exam tends to be a lot higher. And we can see that there's a linear relationship between those two attributes. That's what our end goal is. So now we're going to go ahead and jump right into our implementation. If you guys are interested in following along with me, here are two links. Let me see if I can copy it. Sorry, give me 1 second. So this is the link to the machine learning repository, and this is the link to the code, which is on my GitHub. Feel free to refer to it. So yeah, before I jump to the actual implementation, does anyone have any questions right now? Or am I going too fast? Pace is good. Cool. Awesome. Okay. Awesome. I will take that as a good thing then. Let's go ahead and jump right into it. So if you guys click on that link that I sent in the chat called archive.ics.uci.edu, this is the University of California Irvine's machine learning repository. So if you don't want to click on the link, you can also type in UCI machine learning repository and then just type in student performance data set. It'll literally be your very first link. That'll take you here. Cool. Awesome. I just want to make sure you guys can see this, right? The website, by the way.
You can see it.
Okay, sick. I just want to make sure I'm not explaining a background. Okay. So in this machine learning repository, there's thousands of data sets that have been pre-processed. Now, what do I mean by pre-processed? Essentially, these data sets they're clean. They've been separated on how we want to. There's no empty values. There's no missing values. There's all like numeric values, and that's what we want to reference. So you'll see here for the data set characteristics, it's defined as multivariate. We're not going to be looking. So what that means is basically it has attributes which are consisting of integer values and non-integer values. But since we want to make this a pretty simple model, we're only going to look at integer values, right? So we're going to look at single variable attributes. And yeah, it says it right here, integer associated tasks. You could use this data set for classification or regression. The number of data instances or data items we have is 649. And we have a total of 33 different attributes you can use to train your model, but we're only looking at 5. If you scroll down here, you can see all the different attributes that can be used to train your model. So it starts everywhere from like what school did they go to, what is the gender of the student, how old is the student, where do they live, all the way to like free time. How much free time do they have? What's their health status? What are their absences? It has a whole list of 30 different, 33 different attributes that we can use to train our model. But like I said, we're only going to be using 5 attributes for the sake of simplicity. So yeah, that's pretty much what you want to do. That's what we're going to be working with. So to use the data set, just click on the data folder and then click student.zip. That student.zip folder will open up in your downloads folder, and you can find it within your downloads folder. It'll be opened as a zip file. All you want to do is just extract it from the zip file into a normal folder. And if I go into this folder, right, you'll find there's 4 files on here. There's a math class and a Portuguese class in this data set. We're only going to be referencing the math class data set. So this has the grades and attributes for all students who are in some arbitrary math class, right? I don't know what math class this is, but that's just what this data set we're going to be using is. By the way, if I'm going too fast, guys, don't worry about it because this is being recorded. So you can pause it and you can work at your own pace and follow along with this workshop as you please. Cool. So this code, like you can find it on my GitHub, which I posted in the chat. It's pretty simple. The first thing you want to do is just open up a new file on Google Colab. I like using Google Colab because it comes with all pre-packaged libraries. You don't have to make any installations. It's a cloud computing tool, so it doesn't take up any storage on your laptop or desktop or whatever. It's really convenient to use. So I'm going to use Colab for this demonstration. Oh my gosh, I'm getting caught now. Okay, cool. So the first thing you're going to want to do is you're going to want to upload your data file. Now here you can see I've already uploaded it, but if you don't know how to upload it, just click this button right here and then go into your downloads, go into the extracted zip file and then click on student-mat and click open. And what it'll do is it'll update that CSV or comma separated value file into your folder, into your Google Colab folder. Takes only 2 seconds to upload that. Once you've uploaded that, we can go ahead and start creating our model. Now look at this, guys. It's really simple. All you have to do when creating your model, import, I'll explain it in more depth, but I'm just showing you generally. All you got to do is just import the libraries you'll need, create a data table to store the attributes that we'll be using. So like I mentioned, grade period 1, grade period 2, grade period 3, and study time, failures, and absences. That's all we need. And then finally, it's just this block of code, which I will explain line by line, so don't be intimidated, which will be used to train our model iteratively. So in this case, I'm training my model 1,000 times to see which model, which iteration is the most accurate, right? Finally, Finally, what I do is I'm just picking which model is the most accurate. And in this case, like my model that was the most accurate was 96%. And this is just general statistics of it. And then all we do here, right here, is we make our predictions. We just see this is what our model predicted, and this is what our what the actual expected value is. That's all. In this list of values right here, these are the attributes, attributes that we used to make a prediction. So yeah, so that's pretty much it. I'll explain this line by line. And finally, our last step is just plotting our data. So we're going to be using ggplot to plot what our final grade is with respect to some arbitrary x value. Cool. Does that make sense to everyone so far? That's generally what we're doing. Solid. I will take that as a yes. Awesome. So this is only going to take another 10 minutes. I know people probably have to hop off, but I'll do my best to explain it as effectively and efficiently as possible. First step, you're going to want to import all your necessary libraries. Since we're going to be working with data frames, you're going to need to import the pandas library. Next step, since we're going to be working with lists and arrays to store our information, we're going to need to import the NumPy library. sklearn is the next library you're going to need. It's really important when it comes to working with machine learning because it has a bunch of machine learning packages on there. So like if you're looking for a linear regression algorithm, if you're looking for a k-nearest neighbors algorithm, it has everything on here. It's really simple. And yeah, there's a bunch of courses at ASU you can use to offer this, or you can use to understand this better. So don't freak out if this isn't like very clear. It usually takes a little bit of time. This is not anything too advanced. Like once you go through it once or twice, you'll be like, oh my gosh, this is really easy. It fits perfectly. So yeah, anyways, sklearn is our machine learning library that we're going to be using. Matplotlib is what we're going to be using to plot our data. Pickle, don't know why it's called Pickle, but it's used to save our model. And then from our sklearn library, we just need to import linear model. Linear model is what's used for our linear regression model. Cool. And you're just going to need to import shuffle as well and import style as well from matplotlib and sklearn, just because we're going to be using that to plot our data clearly. All right, so that's the first step. That's all the libraries you're going to need. Now comes the easy stuff. The first thing you want to do, create a data frame. That's what this, wait, before we even create our data frame, we want to read our data from our CSV file. That CSV file was called what? student-mat.csv. We just read our data from there, and we're going to store it in some variable, arbitrary variable called data, right? That will store it into a data frame since we're calling the pandas library. So when I print out this value, you'll see that we have this data frame right here. And this is a total of 33 attributes that we can look at. We're not going to look at all 33. We're only going to look at 5 of them or 6 of them. So after we've stored all of our data into a data variable or into a data frame, we go ahead and extract the information that we need. So we need grade period 1, grade period 2, grade period 3, study time, failures, and absences. And we just store that within a list of lists. That will be stored within our data frame, and that's going to be updated. So this is what our final data frame looks like right over here. Super simple. Consists of G1, G2, G3, study time, failures, and absences. Okay, so this is the most important part, I would say, of this workshop, which is creating the model. The first step you want to do is you want to store the attribute or the variable you want to predict into a predict variable. So since we're predicting our final grade, which is our G3 attribute, we just store that in this variable called predict. In this next line, we're basically storing all the attributes over here, G1, G2, except for G3, into a variable called X, because we're going to be using X as our training data. So this, and when we say np.array data.drop, this array will contain all the values within G1, G2, study time, failures, and absences. That's what this line of code does. It just stores all that training information. In our next line of code, in where I stored in Y, this basically only contains one column of information, and that's G3. And we'll be using this Y as our labeled data to train our model. That's all. Okay, this is that second step that I was telling you guys, which is splitting your data into your training data set and your testing data set. All you have to do is create 2 variables, xtrain, xtest, ytrain, ytest, and you have to follow this respective order because sklearn will throw an issue if they're out of order. So follow that order, and then we just call the model selection function because we're picking which model we want to use. And we're also going to do train.test split to specify like, okay, here we're going to be splitting our data into our testing data and our training data. So here you can see that I passed in X, Y, and test size as my parameters. xy being your data. Test size is equivalent to 0.1. I set that to 0.1 because I want 10% of my entire data set to be used for my test data and 90% of my data set to be used for my training data. Essentially, the more data you use for your training data means that your model is more likely to be more accurate because it has more instances to be used to train your model. Does that make sense? Is everyone following along so far? Cool. Awesome. If it sounds like a bunch of gibberish, just let me know. But anyways, yeah, so that's what we're doing there. We're just splitting our data into our test set, training set. Next thing, okay, cool. The next thing here is we're just setting whatever our best score is to 0. So I created this variable basically to be used to figure out which model is the best model that I want to use after training it a total of 1,000 times, right? So what you want to do is I don't know what, honestly, you don't need this line. I kind of repeated it, but it doesn't affect the code, so that's fine. I just split the data again, and then here you're going to go ahead and create your linear regression model. It's just this line of code that's responsible for creating your linear regression model, and that's from the linear model package that we imported from sklearn. Next thing you want to do is you just want to actually test your data on the training data, or you want to test your data on the training data. You want to test your model on the training data. So basically, we're training our model on these X train data and the Y train data. This Y train represents our labeled data. Once we finish training our model, we want to calculate what is the overall accuracy of our model. That's just simply done by scoring it on our X test and our Y test data. And then I just multiply by 100 just to show you that it's in 2 decimal places. Here I'm printing out what the accuracy is. And then this condition right over here is basically we're checking if our accuracy is greater than our best score, which is being updated each time. So currently our best score is equivalent to 0. We set our best score to be whatever our accuracy was. So what this will do is when it's incrementing that 1,000 times, it'll constantly keep checking whatever the previous score was it better than the new score? And if it is, we update our best score, right? This pickle.dump is basically used to save your model. So once I've figured out what my best model is, I just want to save that model. So what you do is, this is pretty universal. The code stays the same. So you open your pickle model file, and then you just write your model to it as a file, and you dump your model, which I call linear in this case, into that file. And finally, if I wanted to open it, you just call the open function and store it back into linear. And that's how you read in your model. So anyways, like you can see here, the model, sorry, one second, that was an accident. The model is being trained 1,000 times. So it's basically seeing which one is our best model. And whatever our best model is, that'll be stored in our best score variable. Okay, cool. Almost done. Just 2 more blocks and then we're done. So now that our model has been trained 1,000 times, we finally print what was our best model. So here I'm just printing what was the best model by printing out what the final accuracy was, which one was the most accurate model. And we can see that the model that was the most accurate had an accuracy of 96.03%, right? Coefficients, so like I mentioned before, this is a linear regression model, right? So coefficient is just your M, it's just your slope, and B is your intercept. So since we're working with multiple attributes to train our model, so that, ignore this. So since we're looking at study time, or we're looking at grade period 1, grade period 2, study time, what else are we looking at? Sorry, I completely forgot. Grade period 1, grade period 2, study time, failures, and absences. That's what we used in our that's what our coefficients represent. And finally, your y-intercept is just where your line of best fit basically intercepts with the y-axis. And finally, here in this block of code, this is where I'm just printing out the output. So basically, I'm calling my model and I'm telling it to make its predictions using the predict function that's used given through sklearn on my test data or X test. And that'll be stored in our predictions variable. Finally, what I'm going to do here is I'm just predicting like, okay, how many predictions did we make? In this case, we're making 40 predictions. And we're just going to, in this loop right over here is responsible for printing out what was our predicted value, which is this value. What was our data that we used to make that prediction? So this represents grade period 1, grade period 2, study time, absences, failures. And then this is what the actual value is. So you can see here, like essentially, okay, what did our model predict? It predicted a final grade of 10.17, whereas our final grade was 11. So you can see that our model wasn't fully or completely accurate, but it's relatively close. And you just want to keep on training your model iteratively until you find a model with a better accuracy. So if I were to round this to say like 0 decimal places, right? Then you would probably see that it would round it to whole numbers. So you could say maybe it goes to 11, but in this case, since we're taking the floor of this value, it'll be 10. So not every single value will be right. Some of them will. You can see that here, our student's final grade was 12.91, but the expected value was 13. So we were only off by 0.09. So yeah, so that's pretty much it. That's that, and this is how this is unique to this student math data set. So I guess out of their scores, everything was out of 15. So you can use this with other data sets as well, and it'll be just useful there too. But yeah, that is pretty much it. If you guys want to know more about creating models, feel free to join our other workshops. This block of code is just responsible for showing you the trend. So you can see if when I'm plotting my output versus my input, we have a linear model. So you can see there's a linear relationship. As the students' grade 1 exam scores increase respectively, you can see they typically do a lot better with respect to their final grade. And by the way, I was wrong. It's not out of 15, it's out of 20. Completely forgot, my bad. But yeah, that's pretty much it. That's the linear relationship. So what does this say? It just means to say, like, and this applies to all of us, if we do better on our midterms in the past, then we're more likely to do better in terms of receiving the best final grade. And that's it, guys. That's how you develop your own machine learning model for supervised machine learning. I hope you guys learned something out of this. I think it's pretty simple. Like I said, this is recorded. It'll be uploaded onto the YouTube channel in the chat, and you guys can follow along there. But that's all, guys. Perfect. Right on time. Does anyone have any questions?
Yeah, I had a question about Collab, the website you're using. Does that cost anything to use or to run? Is there like a limit to the amount of like stuff you can run on it?
No, not at all. That's one of my favorite things about it. If it doesn't need to be run locally, you can run as many files concurrently.
Awesome. Thank you.
Yeah, of course. Does anybody else have any questions?
Everybody.
Sorry?
So this data set seems like it doesn't have any really crazy outliers.
Mm-hmm. Yeah.
So if it did, would you have to kind of account for underfitting?
Yes, you would. That's what you would have to. That's actually brilliant. Yeah, you would have to take that into account. Typically, linear regression is not really good for. If I remember correctly, it's not good for overfitting. So when you're dealing with outliers, linear regression isn't your best model to use.
Okay, thank you.
Yeah, of course. Does anybody else have any final questions about the club or the workshop, anything in general? If not, that's all I had to say. Ira, did you want to add anything or?
No, thank you so much. That was a great presentation. To some of like the younger CIS BDA students, like this can seem a little bit overwhelming, but you'll learn some Python and data science stuff in your classes later down the road, and some of this will make a lot better sense. And yeah, like you can bookmark this. I think Adwith dropped the GitHub code repository. You can kind of just like bookmark it and then like come back to it like at a later time once you've kind of have a better gone through some of those Python classes.
Yep. And also, just to give you a heads up, it will be uploaded to the YouTube channel. There was a question in the chat, so yeah, it'll be. I will send you the YouTube channel video as soon as we get it uploaded onto our channel.
All right, thank you so much.
Of course.
Yeah, that's it for me, and then I guess I'll stick around if other people have questions and stuff.